Alright, last piece, the complex conjugate root theorem. Alright, so the complex conjugate root theorem says if a plus bi, complex number, an imaginary with a regular number added on there, is a zero of a polynomial function, comma, then a minus bi is also a zero. So they always come in pairs. It's always going to be a plus or minus bi. So you're not going to be able to have one imaginary or complex solution. There's always going to be either 2 or 4. Alright, so you can't have just one. If it's positive, there's going to be a negative version. If there's a negative version, there's going to be a positive version. So here, when I say n equals 3, that's talking about the degrees. The degrees are 3, and our zeros are equal to 3 and 4i, or at least that's the ones they're telling us. Alright. The complex conjugate root theorem tells us that if it's a positive 4i, there's also going to be a negative 4i. Alright, so we're taking our zeros, just like we did in the last video, and writing out the factors. So we're going to have x minus 3, and then this is going to be, so if we have x is equal to 4i, we would do minus 4i, minus 4i, x minus 4i is equal to 0. X minus 4i. Alright, we know the degree is 3, and this is where we need that other one. So, comma, minus 4i. If we've got positive, it's going to have the negative. Well, if this was negative, we would have to add, and so that would be a plus. X plus 4i. And that's where our third piece comes from. Alright? So then we want to start multiplying. We want to go ahead and multiply these guys together. So x times x is x squared, x times 4i, positive 4ix, negative 4ix, negative 16i squared, x minus 3. Okay, so x minus 3 just comes down, and then we have x squared. Now positive 4ix, negative 4ix, those are going to cancel. And then what is negative 16i squared? I squared is negative 1, so negative 16 times a negative 1 is going to make plus 16. Okay, and then so this simplifies down to that, and then we're going to multiply, FOIL again. So x times x squared is x to the third, x times 16, 16x, negative 3, x squared, and negative 3 times 16 is negative 48. Alright, and we're so close to being done, it's not quite in standard form, so we want to take this and say f of x is equal to x to the third minus 3x squared plus 16x minus 48. Alright, it's a third degree function. That's what they told us here, it should be 3, 1, 2, 3. Okay? Let's try one more, because these are very similar to what we were just doing. It's just adding the concept of imaginary numbers. Another third degree. Alright, our zeros are negative 2 and 3i. So that's going to be x plus 2. And then here it's going to be x minus 3i and x plus 3i. Go ahead and multiply those. So x times x is x squared plus 3ix minus 3ix minus 9i squared. These guys cancel, and then minus 9i squared turns into plus 9. The x plus 2 comes down, and we FOIL again to get our answer. X times x squared is x to the third, x times 9 plus 9x plus 2x squared plus 18. So f of x is equal to x to the third plus 2x squared plus 9x plus 18. Third degree function should be third degree, has negative 2 and plus or minus 3i. So 3 solutions. And here's the polynomial that has that stuff.